Next, things get a little more interesting. We have the limit as x approaches infinity, and then also separately negative infinity, of the quantity of square root of 4x squared plus 3x plus 2x. As x goes to infinity, if I use direct substitution, I'm going to end up with infinity plus infinity. Folks, infinity plus infinity is infinity. We're done there. Okay, so the interesting one is the limit where x is approaching negative infinity. Now, what worked for us before was to multiply numerator and denominator by 1 over the highest power of x that appeared in the denominator. But here we don't have a denominator. Or do we? I know, that was bad. We're going to envision a denominator of 1, and then we're going to multiply numerator and denominator by the conjugate of the numerator. So 4x squared plus 3x minus 2x over itself. This is going to equal the limit as x approaches negative infinity of 4x squared plus 3x minus 4x squared over the square root of 4x squared plus 3x minus 2x. And I see that the 4x squareds are going to subtract out. So I have the limit as x approaches negative infinity of 3x over the square root of 4x squared plus 3x. Whoops, minus 2x. I tried to make this a whole lot easier than it is. Okay, now the largest power of x that appears in the denominator is 1, right? So I have here 2x. And then big picture, I have the square root of 4x squared. Square root of x squared, that's going to give me x. So I want to multiply by 1 over x over 1 over x. Here's where things get a little tricky. I can multiply 2x by 1 over x, no problem. But in order for me to multiply the square root, I need to convert 1 over x to 1 over the square root of x squared. But wait a minute, x is going to negative infinity. And so 1 over x is negative. 1 over x is negative, no problem. 1 over the square root of x squared is positive. So I need to make it negative, and now it's negative. What's going on here? Let's write this down. So here we have the limit as x approaches negative infinity of, I'm going to write this whole thing out here, 3x times 1 over x, and then I'm going to write out the denominator, and I'm developing this way on purpose. So I have square root of 4x squared plus 3x, and then I have minus 2x. For the 2x, I can multiply by 1 over x, no problem. But when I distribute that 1 over x to the square root, I need to write it as negative 1 over the square root of x squared. It needs to be in a square root to be the same language as the square root already. It needs to be negative because x is going to negative infinity. Now I've got that this is the limit as x approaches negative infinity of 3 over negative square root of 4 plus 3 over x minus 2. 3 over x goes to 0. This result is 3 over negative square root of 4 minus 2. That's a negative 3/4. Couple of things. Number one, if I didn't remember this negative here, then I would have ended up with the square root of 4 minus 2, which would have been 0. That would have given me the wrong answer. Number two, the original expression was the limit as x goes to negative infinity of a square root plus 2x, right? If I had tried to directly substitute, I forgot to talk about this at the beginning, I would have ended up with the square root of basically infinity squared minus infinity, because remember, it's x is going to negative infinity, and then minus infinity. Folks, infinity minus infinity could be anything. Could be positive, could be negative, could be 0, could be infinity, whatever. But in this case, that answer is negative 3/4. Here I have the graph of y equals the square root of 4x squared plus 3x plus 2x. And as we can see, moving to the right, that's blowing up to positive infinity. And moving to the left, we have a horizontal asymptote. I can't see the actual value here because my scale isn't letting me, but what I can see is that the answer is negative. That agrees with what we found. Now, oftentimes somebody in class will ask me, how do I know when to throw in a negative? Here's the answer. If x is going to negative infinity and I have a square root, then when I multiply by that term, I need to make sure I include a negative. That was true here, and it was true in the previous example. I had a square root, x is going to negative infinity, that's when I need to throw in a negative. But to be a little more specific, it's only the square root term that gets the minus in the event that I have multiple terms.